Hello Chemistry, this is the video that goes along with Lab 28, mixing hot and cold water. This is the beginning of our thermochemistry labs. It's a pretty easy one today. We're going to be doing two experiments where we mix hot water here on the hot plate. It's dyed red so you can see it's hot. And this one here is our cold water and I've dyed it blue just to kind of help us keep track of which one's hot and cold. We have our LabQuest here with 3 temperature probes hooked up to it so we can keep track of our temperatures. And there are 40 milliliters of water in each of the beakers. That's already been measured out for us. All right, so the first one we're gonna do, we're gonna mix the water inside a beaker like this, right? This beaker is not insulated, so make sure you keep track of that. You think about what that means for your analysis. Channel 1, this temperature probe is going to go to our hot water, right? And it's colored in red on the LabQuest. Hopefully you can see that. And probe 2, this one's colored in blue, and it's going to go to our cold water over here. And we'll use the 3rd temperature probe to measure the temperature of the mixture. Now, after I remove these hot and cold beakers from where they are, right, on their heat source or on their cold source, which is the ice water inside this styrofoam. Once I remove those and put them onto the table, we have to move very quickly because remember, the laws of thermodynamics say that as the beaker sits here, if it's hot, it's losing heat to the surroundings constantly, so its temperature will be falling as soon as I remove it from the heat source. Same thing is true for our cold water. As soon as I remove it from the cold water and set it over here, it will start gaining temperature, right? And so it will start sucking up energy from the surroundings. Okay, so we're gonna do this quick. We're gonna move it, measure the temperature, move it, measure the temperature, right? I'll probably do a little bit of measuring at the same time. Then we're gonna mix and measure the final temperatures. The things you need to record for this lab are the initial temperatures of the things and then the final temperature of the mixture, okay? So here we go. We're gonna use our beaker, tongs here. There we go. And this one here. There we go. All right, I'm gonna set this up for you guys. Hopefully you can see this, the temperature. All right, and we're gonna stick these in here, read off those temperatures. Okay. Just kind of let this come to thermal equilibrium here. It looks like we're getting close. Our cold water looks like it's at about 2, and our hot water looks like it's at about 63.4, 63.5. All right, so now we're ready to mix here and here, yes. Let's get the final temperature here with our 3rd probe. All right, so the temperature reading you should be reading right now is that bottom reading, the one in green. That's the 3rd probe. Remember, we started at about 2 degrees for the cold water, and we started at about 63 for the hot water. Make sure you have those readings recorded and this final reading of what looks like about 29.6. Nope, yep, and now we're starting to go back down, right? If we let this sit here over time, this will come back to room temperature, which in Celsius is about 22 degrees. Okay, we're a little bit above that right now. Okay, that was the first experiment that we did in our beaker, right? A non-insulated beaker. The second experiment, we're gonna do the same thing where we're gonna do it in this double styrofoam cup, right? It's 2 styrofoam cups that gives us insulation here. There's a layer of air in between which helps us to insulate, and there is there's styrofoam, which is a good insulator as well. Okay, so we're gonna get set up to go again. Right? There's our channel 3. That is our mixed probe. Here's the cold probe here for channel 2, and this one is the hot probe for channel 1. We're gonna remove these guys here and here. All right, we're gonna do it again with our hot and cold water. I'm going to pull them out of the heat and cold sources there and there. All right. We're going to quickly measure their temperatures, remember. All right, we should get pretty close to about the same temperatures that we had before. All right. This one looks maybe a little bit colder there. It's 1.6 degrees. And here, maybe a little hotter. Oh, let's go with 1.7 and 64.2. All right, we're going to go ahead and mix them. Measure the final temperature. Let's see what we get up to. Remember, this is the green one is the one we're looking at now. Oh shoot. We're up to 30, 30.1. 30.2. Right, it looks like about 30.2 is the maximum temperature here for our insulated measurement. Okay, so that's the end of the data that you need to record in your lab notebook. From there on, it's just analysis. You will be determining the amount of heat that was gained or lost by the hot water using Q is equal to MCAT, and the energy that was gained by the cold water, Q is equal to MCAT there as well. They've come to thermal equilibrium, so that means their final temperatures should be the same for both the hot and the cold water, although their initial temperatures that we measured were different. All right, I'm here if you have questions.